Hello and welcome to a recorded lecture for research methods. In this lecture, we will be talking about defining and measuring variables. So we are going to look at measurement, different types of measurement. We'll look at constructs, how to define that, what they are. We'll look at types of variables, very similar to what you get early on in stats. And we'll finish with modalities of measurement. An important concept in science, in psychology, when we're talking about doing research is identifying a good measurement. Science requires that we measure things well. We don't have to measure it perfectly, but we have to measure it well. And to measure it well, we need to identify the best way that we can measure it. So measurement, it's not often straightforward in psychology when we're looking at measuring things that are internal. It can be more difficult to measure these things that are internal if we're trying to measure it with external reasoning. So when we measure, let's say, motivation or emotion, we have to define what we're talking about when we say motivation. And then we have to find a measurement that measures what we are defining. So it's when we're talking about this in psychology, it's often going to be that we are measuring something that we can't measure directly, we have to measure indirectly. This actually was early on in psychology, caused a lot of issues because early psychology, there was a lot of these internal things that were being studied, but there was no real external way to measure them. And that's why they switched for a while to only external measurable things as a study of psychology, then went back to the internal, and now we're at a mix of the two. But when it comes down to it, there's two types of variables involved in psychological research. Well-defined, easily observed, and easily measured variables like height, weight, things that we can clearly define and easily observe and easily measure. But then there's the more likely things in psychology, and these are intangible abstract attributes. Things like motivation, self-esteem, all of the different personality traits. Psychological disorders fall under this. And because of this, the definition of what we're measuring can be variable, but the definition is important, but it's not as easily measured. Typically, what you're measuring is characteristics of a trait when you're really trying to measure the trait itself. So you are indirectly measuring the trait. If you recall back to the research process that we talked about before, the third step was determine a method for defining and measuring the variable being studied. So that's basically what we're doing in this chapter. We are working on basically defining the variable and finding ways to accurately measure it. So variables are going to be characteristics or conditions that change or have different values for different individuals. We talked about this. This was, again, part of the earlier lecture, but now we're going to look at it in the context of, or we're going to look at it deeper. To do that, we have to talk about constructs. So what are constructs or hypothetical constructs? Hypothetical constructs are hypothetical entities created from theory and speculation, cannot be seen but are assumed to exist. Behavioral characteristics. Let's talk about, let's say, we'll use the example of extroversion. So extroversion is a hypothetical construct. It is based on theory. It cannot be seen directly. It's assumed to exist, though, and there are characteristics of it that can be measured. So these hypothetical constructs help explain and predict behavior in a theory. So another example is intelligence. It can be defined, it comes from theory, but what are we actually looking at? You can't see IQ. You can measure IQ as a test on an IQ test, but are you actually measuring IQ? No, you're actually measuring different things, and you're consolidating those different things into intelligence. Hunger, when we look at an operational definition of it, it could be defined as the number of hours of food deprivation. There's obviously going to be more to it than that, because it could be that you've had little time since food deprivation, but the amount of food you're bringing in is so small. And that's why these operational definitions, these constructs, can be really difficult, because there's so many different components of it, so many different parts of it to take into consideration. We can't just look at one thing and say, okay, this is the concrete definition. No, the problem becomes that you can always point out instances where your concrete definition doesn't apply, unless your concrete definition has all these circumstances in it. So when we're talking about a construct and this operational definition that we have for constructs, you have to be aware that they are going to miss fringe cases. It's also why in psychology, when we define different things, when we define things like extroversion, when we define narcissism, when we define intelligence, when we define all of these, it can be very difficult because of the fact that some things that should fall under it don't fall under that definition. Let's look at some of these limitations then of operational definitions. An operational definition is not the construct. An operational definition is the explanation or our definition of what the construct is. So again, this is kind of going back to what I was talking about on the previous slide. Let's say we're using extroversion, been using that all along. If you operationally define extroversion as someone who is outgoing, willing to start conversations, willing to make friends, all of that, and you include a whole bunch of things in your operational definition for extroversion, that doesn't necessarily mean it's the construct itself. The construct itself is the internal processing that leads to the behavior. But we can't operationally define we can't exactly explain the construct. That's why we form the operational definition, which is our best way of explaining it. So there are some concerns about the quality of operational definitions and the measurements produced. So it's easy for operational definitions to leave out important components of a construct. This is what I was saying before, especially if you've got multiple different researchers studying the same construct. They could have different operational definitions. They could be looking at different things. You could miss an important component. And operational definitions often include extra components that are not part of the construct being measured. Since we can't know exactly what extroversion is, we have to come up with the closest definition we can get. And sometimes our definition is going to include things that are not part of the construct. And the only thing that fixes this is time and research. So that's another thing. As more research is conducted on the construct, our operational definitions tend to become more exact. Let's talk about variables. And we're going to talk about variables for a little bit now. We're going to look at different ways to measure variables, different types of things that go into it. I'm not going to go as in-depth as I do in stats, but I am going to talk about some of the same things. So a variable is anything that can take on a different quality or quantity. Of relevance to research, you've got independent variables. Independent variables influence the dependent variable. Independent variables are variables that are manipulated in an experiment. These are the ones where the experimenter will change or assign different people to different conditions. Let's look at it when you're talking about, let's say we're looking at a drug and we're trying to see if this drug reduces pain better than existing drugs. So we apply 3 conditions. We apply one condition as the placebo condition, they just get a sugar pill. Another condition gets aspirin. And the third condition gets our new drug. And we want to compare it to the placebo and the aspirin, the new drug. The independent variable is the drug given. It is the variable that was manipulated by the experimenter so that they, whether they get the placebo, the aspirin, or the new drug. So people are randomly assigned. My experiment that I did, I've talked about it a little bit, but where I tested mate retention behaviors, and I had a confederate. My independent variable was whether they got a male confederate, a female confederate, or no confederate at all. So those were the different conditions. Levels is the levels of treatment or the treatment conditions or the different groups within the independent variable. So levels in this case is going to refer to, let's say we're talking about our drug example, the different levels is placebo, aspirin, new drug. Those are, so it's got 3 levels. My experiment, male confederate, female confederate, no confederate, had 3 levels as well. And then you've got dependent variables. Dependent variables are outcome variables or measured variables. These are not manipulated by the experimenter. These are ones that are assessed by the experimenter. So these are ones to see if the independent variable has an effect on dependent variables. Dependent variables do not have levels, even if there's different things that are being there's different rates at the measurement. So let's say we were looking at pain and we had a scale of 1 to 10 on pain. We've got that as a scale, but those aren't counted as levels. Should also point out, not all experiments have independent variables. Some experiments have multiple dependent variables. So when we look at the labs we're doing in this class, and you're going to eventually be having surveys that you're going to put out, and we're going to put these surveys out, you're basically only going to have dependent variables. You're going to have measured variables, because we can't assign people to conditions for what we're doing. We're just doing something really easy. We're doing multiple dependent variables. If you're doing measurements with multiple dependent variables, you are basically doing correlational research. So when you're examining 2 dependent variables and their relationship, you're doing a correlational analysis. So that's the basic analysis we'll be doing this semester for our research. But the stats isn't an important component. Really, what's the component is the important for this class is all of the steps in the research process. When we're talking about dependent variables, we've got different types of, not dependent variables, when we're talking about variables, we've got different types of variables. We can have a qualitative variable. This is a variable that's a discrete variable that varies in kind. What do I mean when I say it varies in kind? When I say it varies in kind, this is a variable that's going to be a categorical variable, a nominal variable. It's going to be a variable that it doesn't matter what the number applied to it is. What I mean here is, let's say we were talking about different makes of cars. Chevy, Ford, Toyota. These vary in kind, but they don't vary in size. So Ford isn't greater than Chevy in size. Chevy isn't greater than Toyota in size. They just vary in kind. Conversely, quantitative variables are variables that vary in amount. So these are variables that vary in how much amount there is. So for this, you're looking at things like height or other different things like that. All of these different variables that can be measured. Sorry, I am manipulating this slide as I'm talking. These are variables that have a quantity. They tell you how much. So even when we talk about our pain levels, that would be a quantitative because we're talking about different levels. We're talking about quantity. whereas qualitative is talking about categories. Okay, on the previous slide, I was talking about qualitative variables, and I was also using the word categorical variable there. Let's actually look at categorical variables and look at those when we're talking about this. So a categorical variable is going to be a name or identifier of a particular characteristic. A categorical variable isn't going to look at how much, it's just a name. So some examples might be nationality. So we've got names here. You've got these names here for different nationalities. However, to ease data entry and analysis, we tend to assign numbers to categorical variables. When you're working with SPSS, you assign numbers to the different categories so that you can organize them better. That doesn't mean that number means anything. That number is completely arbitrary. It is not meaningful. It is just an identifier. Again, when we've got these numbers, we've got applied here 1 for US, 2 for Canadian, 3 for Mexican, 4 for other. You could rearrange these numbers and it wouldn't change anything about your data set. 3 could be US, 1 could be Canadian, 4 could be Mexican, 2 could be other. These numbers don't mean, 1 doesn't mean greater than 2, 2 doesn't mean greater than 3, 4 isn't larger than 3. The numbers don't mean anything except as an identifier. So when we're talking about a categorical variable, we're talking about a variable that has names. So when you've got a categorical variable, you can't compare one to the other in terms of one is greater than the other or one is less than the other. Now, let's say we were coding these categorical variables and we had US, Canadian, Mexican, other, and we counted how many applied to each. Then we could compare them saying, well, other has the most in our data set. US has the second most, Canadian has the third most, Mexican has the fourth most, however you're doing it. However, that being said, the variable is still categorical, but you've got a measure of it that is something that we could do analysis on and stats on. You can't do direct analysis on a categorical variable. You can, but really you're looking at the quantity of that variable. So we'll talk about that later, and if you get into stats, that's where you do things like chi-squared tests. So the number indicates that we're noticing a difference, but there's no claim that US citizens are 3 times as blank as Canadians are. So again, what I've already been saying. Next, let's look at scales of measurement, and then we'll get to levels of measurement. So scales of measurement are basically, since measurement is a procedure for classifying individuals, scale is a set of numbers or categories used for classification. So the process of measurement involves 2 components, the sets of categories and the procedure for assigning individuals to the categories. These categories in this case can be different numbers. Let's say we've got, so we're talking about categories different here than we're talking about categorical variables. Our scales of measurement are more of different groupings we apply people to. So let's say we're talking about pain, like where we're using with our example earlier. We've got 10 levels of pain. So in that case, we're going to have 10 categories. And we're going to assign individuals to those 10 different categories. And that is our scale of measurement. Let's say we were talking about weight, though. One thing when we're talking about scale of measurement, we have to talk about precision of measurement. So if we're talking about weight, your scale of measurement might go into the tenths. It might be just even pounds. It might be tenths of a pound. It might be hundredths of a pound. If you're measuring with a very precise scale, it could be thousands, 10,000s, 100,000s. It could go down to many decimal places. So the scale of measurement is the scale of measurement is the categories we're applying things to, within our variable. The precision of measurement is how precise our categories are. Let's look at levels of measurement. So when we're talking about levels of measurement, we're going to have 4 different levels of measurement we're going to look at. The first is nominal. Nominal is also categorical. It's also it is also qualitative. So it's the same essential thing, and basically nominal is Latin for nomen, which means name. Data that's nominal is categorical. It's separated into categories. So you're going to have things like I said before, Ford, Chevy, Toyota, that would be a nominal variable. American, Canadian, Mexican, nominal variable. When we have a nominal level of measurement, it's always going to have mutually exclusive categories. Mutually exclusive refers to any individual observation cannot be in 2 or more categories. It can only be in 1 category. So when we look at it, when you have, let's say, like I said, American, Canadian, Mexican, well, what if somebody who is a citizen of 2 of those? Well, that's why the other category was there. So the other category is going to encompass people who are citizens of more than 1, so they would not fall under the American or the Mexican if they had dual citizenship there. So you have, relating to that, you have collectively exhaustive, meaning you must have a category for every observation, and every observation only fits into 1 category. However, with levels of measure, with nominal, there is no true zero. So a 0 is just like all the other numbers, 1, 2, 3, 4, whatever you're assigning. If you assign somebody a 0, it's arbitrary. You'll often see this when you're assigning gender. Gender typically does 0 and 1. 0 for male or female, 1 for the other. And of course you're going to have other ones if needed, but a 0 doesn't mean the absence of something. So a true 0 means the absence of. A 0 doesn't mean the absence of what you're measuring in this case. So some examples here: sex, political affiliation, and other ones I've given already. The next category is ordinal. So ordinal is going to now, we don't have categories. Now we've got numbers that actually matter. So ordinal is when you are ranking observation based on whether one is greater than the other. However, it does not tell you how close the observations are from one another. So for examples like this is when you're talking medaling in the Olympics. You've got a gold medal, a silver medal, and a bronze medal. It doesn't mean that the gold medal and the silver medalist, the distance between them, whatever they were doing, or the score between them is exactly the same as it is between silver and bronze. It just means that we know the order. There is no true 0 though. A 0 in ordinal doesn't mean the absence of something. It just, again, it's where it is in the order. So things here like your class rank, your finishing position in a race, Olympic medals, things like that. So the order is important, but the distance between your observations, your categories, is not consistent, is not known. It may be consistent, but it's not known. Next one is interval. Interval is going to take our ordinal, but now it's going to add the component of equal separation between each value, between each category. So the different distance between 1 and 2 is the exact same as the different distance between 2 and 3, is the exact same as the distance between 100 and 101. We can tell which is greater, and we know by how many units because the distance between numbers is consistent. However, interval still has no true 0 because 0 does not imply the absence of whatever it is we're measuring. We'll get to that with the next one. You can't say 100 is twice as large as 50 because 0 is an arbitrary number on the line. It doesn't mean the absence of something. So an example here is SAT scores. 0 is not an absence of an SAT score. Fahrenheit and Celsius temperatures, because 0 doesn't mean absence of temperature. That would be Kelvin. And the final one is ratio. Ratio has all the properties of interval, but it has an absolute 0, meaning that 0 means a true absence of something. Therefore, we can make ratio statements. A is twice as much as B. So examples here are Kelvin temperature scale, which a 0 means the absence of temperature, or height, specifically when measuring from the ground. Let's talk about that and show what I mean and see the difference between interval and ratio. So let's say we are measuring height, but in my art is really bad, but in our interval example, we've got a table. Must be a really low table. Stick figures. So in interval and ratio, the difference between these is where 0 is. So in ratio, the 0 is going to be at the ground. Height is measured from the ground up, and a 0 at the ground means the absence of height. It is at the ground. It means there's no height at all. However, in this instance for interval, we're measuring height from the top of the table. So a 0 here doesn't mean the absence of height. That is because there's still distance down below. And let's say we had someone who was, let's say this person is 4 foot tall. We've got a short person. The table is 2 foot tall. And another person here is 6 foot tall. Really great art, right? This person is 6 foot tall. Is the person who's 6 foot tall twice as tall as the person who's 4 foot tall? No, that is not the case. If we were measuring over here, if we were measuring from the ground, the person who's 6 foot and the person who's 4 foot, you can say that the person is 2 foot taller. If we had an 8 foot tall person, we could say that they're twice as tall. However, when we're looking at it over here, let's actually look at it. Let's change this 4 foot tall person to a 3 foot tall person, just for these ratios. Is the person that's 6 foot tall twice as tall as the person that's 3 foot tall? From our ratio, we can say, and that's why the term is ratio, because we can make ratio assessments, ratio statements. The person who's 6 foot tall is twice as tall as the person who's 3 foot tall. However, if we're measuring from the top of this 2 foot table, the person on the left is only going to be 1 foot tall. The person on the right is going to be 4 foot tall. The ratio statement, if you made it there, would say that this person, the person who's 6 foot tall, is 4 times taller than the person who's 1 foot tall. We can't make that ratio statement though, because it's an interval measurement. 0 here and 0 here is not the absence of height. It is just an arbitrary starting of our measurement. So when we've got interval, we can't make these ratio statements because 0 doesn't mean the absence of. However, when we've got a ratio scale of measurement, 0 means the absence of, so we can make those ratio statements. I hope that makes sense. Let's do some practice here. What is these different what is the scale of or the level of measurement for these different things? How about marital status? If you said nominal, you are correct, because marital status is a category. Married, not married, single, divorced, all of those, whatever your marital status is, those are categories. Numbers don't apply. How about IQ of your classmates? This is a confusing one. I put it second. I should put it at the end. It's a confusing one because it could be interval. It also could be ratio. Does 0 mean an absence of IQ? Well, what really matters here is your operational definition of IQ. This goes back to what we've been talking about before. The fact of the matter is it could even be ordinal if what you're measuring doesn't have the same distance between different measures, if you're just measuring people based on ranking. So that's when we're talking about these levels of measurement, it's important to look at these as something that you have to consider. It's not always cut and dry. Medalists, this one is an example I already gave. It's ordinal. Hometown, we're back to nominal because we've got names. How about numbers of words memorized remembered on a memory test? Does 0 mean the absence of? Yeah, you remembered 0 words. So it's ratio. The difference between 1 word and 2 words is the same as between 12 and 13. So the distance is there, and 0 is ratio. How about driving speed? Same exact thing, ratio, because 0 is the absence of speed. We're not considering the rotation of the Earth and the movement of the solar system, movement of the sun around the Earth around the sun, the movement of the solar system, the movement of the galaxy. We're not taking all that into consideration. We're talking about 0 being the absence of speed on Earth. So when selecting a scale of measurement, we want to use basically the most complex we can, as long as the measurement fits it. So when we're doing stats, we want to do the most highest power stats we can. Power is something in stats that refers to how strong a measure is. Now, each statistics test has specific requirements that must be met in order to do that test. So when you're doing a test and you've got the different power, you're looking at basically doing a test, but you can only do it if those conditions are met. So when you're looking at those conditions, if you fudge it and say, okay, well, I'm going to ignore this condition and do that test, then that test becomes invalid and it loses power. So when we're doing it, like I said, we want to use the highest scale of measurement we can. Nominal is the lowest, but again, if our variable is only nominal, then we have to use it. Ordinal is the next higher, indicates direction of the difference, but not quantity. So for that, we use ordinal whenever we've got something like that. We'll also use ordinal if we've got extreme outliers. So things like that can cause us to use ordinal as well. Then we use interval if we can, and finally we use ratio if we possibly can. Let's look at another distinction when we're talking about types of variables. So another distinction is the difference between continuous and discontinuous. Another way to mention discontinuous is discrete. So when you're talking about the difference between discrete and continuous, you're talking about units. You're talking about the unit of measure being done for it. So a variable that comes in whole units, and it's not just the unit of measure, it's the unit of possible measure. So any variable that only can come in whole units or specific segmented parts of units, I'll come back to that in just a second, is considered discrete or discontinuous. It's either there or not there, usually expressed as some finite number. How many children do you have? You can't have half a child. So you've either got 0, 1, 2, 3, however many. How many houses are there in Flint? Well, you can't have half a house. It's either a house or it's not a house. The exceptions are sometimes when you're talking about specific like halves of units. So when you're talking about the grade you get in a class in a number format, in its GPA format, when you're talking about the grade for one specific class, you can have however that's looked at as an A minus, as a 3.33 or 3.5, however it gets looked at. The point is that it's specific. You can't have between an A minus and an A. So if an A is a 4.0 and an A minus is a 3.5, You can't have between the two of those. You can when you average, and that's the thing. We talk about it, you can have the average amount of homes in a city, you can have partial now. The average number of children people have, you can have partials now. But when you're talking about a specific number, you can only have these specific discrete quantities, then it is considered discrete or discontinuous. Conversely, continuous is any variable that forms a continuum and can be represented as fractions in whole units. So when we talk about something like weight, weight is going to be continuous. The limiting factor on continuous variables is our level of measurement when we're talking about how fine of a measurement we have, our precision of measurement. So I talked about earlier about the scale. A scale might only show you weight in whole pounds, but that doesn't mean it's not a continuous variable. It's still continuous. You still can have you still can weigh fractions of a pound between two different weights. The fact is, it's just because your scale only measures pounds doesn't mean that those partial fractions of units don't exist. So things like weight and height are always going to be continuous. Things like the number of children you have, how much money do you own? That's another one that's discrete. How much money do you have? You can have a fraction. You can have cents. So you can have in your wallet or in your pocket, you can have $10.12. That's still discrete though, because you don't have $10.12.375467 I hope that makes sense. I cracked myself up. Okay, let's look at modalities of measurement, the types of measurement that we can do. We can do self-report measures where you ask participants direct questions to study behavior. This provides a direct measure. However, validity is dubious. We will talk about validity later. But self-report measures, this is what we'll be doing for our study in here because we're just going to do self-report survey. The issue with validity or the issue with self-report, well, like I said, we'll talk about validity and reliability in the next lecture. But the issue with self-report is people tend to do things like lie. And they might not even realize they're lying on their self-report. Conversely, you've got physiological measures that are based off manifestations of the underlying construct, such as GSRs, galvanic skin responses, MRIs, fMRIs. These provide an objective measure but require expensive equipment, and we don't have valid ways with physiological measures to measure every construct. It only can measure certain constructs. Even when we're doing like brain imaging, we can still only measure certain constructs. So we can't do these physiological measures for those. We can either do self-report or we can do behavioral measures. This is based on overt behaviors rather than physiological. So this is where we observe and measure a actual behavior. And this leads to lots of different options. It's possible to select various different behaviors that seem best for defining and measuring our specific construct. However, behaviors may only be temporary or situational indicators of the underlying construct, but this does allow us to measure them at specific times, especially if we elicit the behavior. Things like that. But it's not as easy to measure as self-report, because with self-report, you can just say, hey, do you do this? Now you might get them lying, you might get them not recalling correctly. Whereas a behavioral measure, what if it's a behavior that only arises, let's say, in the privacy of their own home? Stuff like that. It's not as easy to measure as a behavioral measure, so that then when you have to do the self-report. In actuality, what do research scientists like to do? They prefer to do multiple measures. Multiple measures provides more confidence and validity in the measurement. You should do as many measures as feasible. For instance, my dissertation, I did the observable thing where I looked at their observable behavior, so it was a behavioral measure. How close together were they sitting? How much were they touching? This was recorded and measured by researchers to look at how close they were, so it's a behavioral measure. I also gave them surveys where they had to fill out a bunch of surveys and answer a bunch of questions, so that is a survey response. I also took testosterone samples, saliva samples, so that is a physiological measure. And then I used all these together to come up with my results. However, you can have problems. It can lead to complex statistical analysis and interpretation, especially when you've got all of these things going together. If you've got two different measures that you're trying to measure the same thing, one, let's say physiological and one behavioral, and there's no agreement between the two measures, that's a complication. But that's actually a valid thing to report to, because if you're showing a lack of concordance between these, especially if you can show a lack of concordance between survey measures and behavioral measures, you're showing that the survey isn't exactly accurate. You can, though, combine the measures into a single score for each individual. This is actually something that's quite often done when you're looking at it, when you're comparing them to other things. And I looked at comparisons between scales, and then I did a combined method too to look at giving each individual a summation score, and then being able to use that as a level of analysis. There are some issues that can arise from basically the effects of measurement. One thing is when a measurement is not sensitive enough to detect a difference. So when I was talking about that with weight, if we're measuring pounds and it only shows it in whole units, or let's say it only shows in hundreds. So you only got 0 pounds, 100 pounds, 200 pounds. You can't really tell a difference between two different people who are maybe even 10 pounds apart because it's only showing it in hundreds. So that is where your sensitivity of your measure, or your precision of your measure, is important. There's also other things relating to range effects, such as ceiling effects. This is where you'll have cluster of scores at the high end of the measurement scale, where it allows little to no increase in value beyond that. So when everything's clustered together, you're not getting much difference between what you're measuring. The same is true in the other direction, floor effect, where you get clustering of scores at the lower end of the scale, allowing for little to no decrease in value. And when you get this, you can have an issue with being able to make comparisons because everything is just so close together. Okay, let's talk about error real quick before we just finish this up. So one of the things to talk about is artifacts. Another way to say artifacts is error. Artifacts or error is when a non-natural feature accidentally is introduced into something being observed, causing what you're being observed to be, in a sense, corrupted. One of the biggest forms of this can be experimenter bias. This is where the experimenter's expectations of what is going to happen in a study affects the outcome of the study. This is why when I had Confederates, I couldn't tell the Confederates in my study what it was I was measuring. Because if I told them what I was measuring, then it could change their behavior if that happens. So like I said, I was interested in people sitting closer together, touching each other more. If the Confederates knew that that's what I was looking for, then when the couple moves together, they could look at that, and that could cause the couple to move farther away. So this is something where you have to have the experimenter blind to the hypotheses. What do I mean by that? Well, let's look at when we're talking about being blind to a study. So a single blind experiment is where the research study is conducted by an experimenter who does not know the expected results. However, the participants would know what's being studied. So the researcher doesn't know what's studied, the participants does. Now you might ask, how can a researcher not know what's being studied? Well, this is where you've got a primary investigator. So like for my study, I was the primary investigator. I knew what was being studied, but I had research assistants who basically ran the study. They brought in participants. I recruited the participants, but when they came into the lab, they met with a research assistant. The research assistant did all of the steps of the study. The research assistants didn't know what I was looking for until the study was over. And along those lines, then the research assistants wouldn't influence the study. So the researchers were blind, but the participants might have known because it might have been in the informed consent. However, a double blind, and this is what is typically done in the sciences, is where neither the experimenter nor the participants know the expected results of the study. So this is where even in the informed consent, it doesn't say exactly what you're looking for. It might say what they're going to do, but it doesn't say what they're looking for. And the experimenters, the research assistants, don't know as well. One issue, though, with the double-blind experiment is that participants aren't dumb. Participants are pretty smart, and participants actually expect to be deceived in psychological experiments. They expect what they're being studied on, they expect it to be either different than what they've been told or more than what they've been told. So they look for these things during a experiment. And this is what brings us to demand characteristics. So demand characteristics are any potential cues of the features of the study that would suggest to the participants the purpose and hypothesis of the study and influence participants to respond or behave in a certain way. So like example, in my experiment where I had Confederates come in, the participants may have suspected that that was a Confederate, not someone that was there, not part of it. And with those, along those lines, what ends up happening is you, at the end of the experiment, you ask a question: did you suspect anything about the experiment? And if you get people who suspected, who said, yeah, that was a Confederate, then you have to toss out their data. You can't use their data. So reactivity is where participants modify their natural behavior in response to knowing that they are in a study. Reactivity happens no matter what. However, one thing we know about reactivity is some things increase it. Knowing you're being recorded increases reactivity. However, that being said, there's studies now that show that even people being recorded, after a short time of being recorded, they forget they're being recorded and go on with more of their natural behavior. If you watch things like reality shows, the ones that aren't scripted, reality shows that aren't scripted are more, you ask yourself, why would they do that? They know they're on camera. They don't even think about the cameras by that point in time. Sometimes it only takes 5 to 10 minutes for someone to become used to a camera and go back to their natural behavior. Okay, so when we've got demand characteristics and participant reactivity, when the participant suspects that they know what's going on and they react in certain ways, these are the ways they can react. One is the good subject role. This is where knowingly or unknowingly the participants support the experimenter's hypothesis or what they suspect to be the experimenter's hypothesis. So the good subject role, they're not acting with their normal behavior. They're acting in such a way that's going to support it. This isn't like they're supporting it because that's their natural behavior. They're supporting it because that's what they, in their mind, consciously or subconsciously, suspect that's what the experimenter wants. So that's what they do. The next is the negativistic subject role. This is the opposite of that. This is where knowingly or unknowingly people act contrary to the hypothesis. So they suspect it or the suspected hypothesis. So they are knowingly or unknowingly sabotaging the experiment. The apprehensive subject role is where subjects attempt to present themselves in a good light. They don't even have to know the hypotheses. This is where participants who, like if you're doing a study on drinking, who will act different than they would normally act because they know they're being studied, and as a result, of knowing they're being studied, they act in a way that is more indicative of how they should act, how it would be morally correct to act rather than how they actually do act. And then the final reactivity is the one that follows these subjects to the letter. This is your ideal participant because regardless of what they know about the experiment, they're following the instructions to the letter, they're acting in their normal way. So in this case, this is where you're getting actual good quality behavior. So how do you select a measurement procedure? And we'll be getting to this in a little bit, but one of the things to keep in mind for the labs in this class, we're still doing survey reports, so you can't really do much there. But what you should do is you should start by reviewing past literature. Your first step in most research studies is to do a literature review. So for the lab this week, that's what we'll be doing. You should use the conventional way of measuring a variable so that your results can be compared to previous studies. If there's already a way of measuring a variable, and that way has been tested and proven to measure that variable, you don't want to reinvent the wheel. You don't want to come up with something new, because then you've got to do validity studies on that new measure and all that. Unless that's what you're interested in. If you're interested in creating a new measure and doing validity studies on it, then that's perfectly fine. But in general, you're going to want to use a way of measuring a variable that's already been constructed. Plus, if you use it that way, you can then compare it to previous studies that measured that variable. If more than one procedure exists, consider which will best answer your question. Especially consider how much sensitivity and measurement you'll need. Possibly even use more than one. Okay, that's all I got for you today. We talked about measurement, we talked about construct, we talked about types of variables, various different things there, and we finished with modalities of measurement and some things on error. Thanks, come on back.